Hey everybody, I want to make a quick video for you folks here in AIT 1501. We're right in the middle of our troubleshooting module in this first lesson, and I thought this would be a really good time to bring to you something I ran across yesterday. It's really kind of cool this week. So anyway, try to bring these real-world examples to you. We do the best we can in our lab and things like that. But this was a real-world example that I got a call for, and so I want to share it with you guys. Our good friends at Hopkinsville Brewing Company in Hopkinsville, Kentucky, they are our brewing partners. They're our partners for our program, the Fermentation Science Program. Great guys and gals down there. They do a super job. But anyway, they called me and they were having trouble heating the liquid in one of their vats, one of their vessels, okay? And so, they had changed some elements and things like that, and it was waiting a long time. And time is really of the essence in a process like this because it is a linear, step-by-step series of processes. And so, one has to perform just like it needs to before you can go on to the next step. So we're waiting a really long time for this water to heat up. Let me give you some background here on this, okay? So this is a general brewing system. They're all the same pretty much, but you got a hot liquor tank. This is basically a hot water tank, and it's heated up with an electric heating element, okay? And then once that temperature reaches a certain temperature, depends on what kind of beer they're making. Sometimes we use about 151, 152, somewhere in that neighborhood there. They'll transfer that water over here into the mash tun where they've got the grains, the different types of grains, fermentable grains, and that temperature mixing with those grains will extract fermentable sugars. And basically they'll open a valve, and this is a false bottom right here, and it will strain out the grain and allow just the liquid to come up here. So this liquid is basically sugar water, okay? That it's because they've extracted the sugars from the grain. And the sugary water, warm sugary water, you can taste it. It tastes just like I said, warm sugar water. They'll transfer it into the boil kettle. And here's where they were having the problem. And just like the hot liquor tank, they've got a heating element over here in the boil kettle that will bring this solution to a boil above 212 degrees, okay? Now, this is typically what one of the elements looks like in that boil kettle, okay? If you can see, this is a simplified version. Here's one in a ton here, boil kettle. And what it is, you stick it from the inside out, and there's a seal right there to keep the liquid from running out of the side of the vessel, obviously. But it's a seal there. It's got an electrical plug on it right here, so the wall of the vessel will be right here, so it's separated. But they've got 3 of these elements in that boil kettle, okay? And it really depends on what size of the kettle it is, the vessel it is, that determines how many elements you have. But in this particular case, they had 3 elements, okay? And they had an AF30 contactor that when they needed the temperature to start heating up, to the voltage to go into the current to go into the heating element, this contactor will close, and there's 3 lugs, and this is a 3-phase contactor, but they're only using single-phase lines because each one of those elements is just a single-phase element. So it's not a 3-phase system, but they're using this 3-phase contactor because they had 3 elements. So you had power coming into L1, 2, and 3, leaving out on T1, 2, and 3 down here to each one of those elements. So as the vessel needed to be called for more heat, the contactor comes in, current flows to the heating element, heats up the solution, the wort as they call it in the industry, to heat that up. So that's how that works. And again, they're heating all 3 elements, okay? And what they wound up finding that themselves was really good. They were not going to wait on me. I couldn't get down there that day. So they did a little looking and a little checking around, and sure enough, this is the actual picture of the contactor. And you had a burnt lug right here. You had a very loose connection right here that got real hot, okay? So, and they had lost another one of these prior to this too. So this joint right here got loose. And now for those of you who've been through my 2101 class where we talk about vibration analysis, we know that electricity, AC electricity, it cycles at 60 hertz per second. And that, you have to remember the math that we did on this, 7,200 cycles per second. That's the vibration that electricity usually has. So it's a lot of building and collapsing. So it's literally vibrating. It's something you can't see, but sometimes you can hear it. But it got loose and wound up burning one of the lugs right there. Okay. Now, we went down there, and obviously they found it with using some very basic common sense tools. They did a great job. They started looking around, seeing what they could find that was obvious, okay? They found that it was obvious. They changed the contactor off, and they were off running, okay? But when I went down there with a thermography camera as well. And what the thermography camera will show you is hot joints, much like this one here. This is where the lug was loose, and you'll see it nice and white. Now it looks like it's just about to explode. It's not. It's relative to the rest of the temperature around it, okay? But relative to these two conductors here, this one right here was really warm, and you can see it's localized. That's telling us it is a hot joint. So we were able to look at that. They didn't need the camera, but it was just something I thought I would bring down there to scan the entire cabinet. And as a result, we found some loose connections, so we fixed those very quickly. And follow-up action is going to be, we're going to do some preventive maintenance in that cabinet, tighten some terminals, look at some connections and things like that. But my point is that we used that thermography camera, and this was the conductor, one of the wires, and you can see right here it's nice, and the copper is nice and shiny here. And here it's kind of brown. It's been exposed to a lot of heat, okay, where that loose connection was, all right? So all this to say, this is just a real-world example, and from that we take a few things. Number one is not everything's textbook, okay? I know that you're working in the lab, and you'll either have motor windings go bad, or you'll have a contactor coil go completely bad, or these are very cut and dry, very basic things. That, you know, there's only so much we can do in troubleshooting here in the lab. A lot of your, 95% of your experience is going to be, or your troubleshooting exposure is going to be due to real-world experience, just like the folks down at Hopkinsville ran into this week. But so not everything is going to be textbook, not everything will be cut and dried, and just exactly so. So you're going to have to learn, you'll see some more, and you'll think, hey, I remember seeing that at one time. Another thing, look at the problem from a systemic level, from a 10,000 foot view. Let's see what's going on, okay? Maybe it was, maybe it was electrical, maybe it was mechanical. Hey, who knows? Maybe that contactor wasn't coming in all the way, because in a dirty environment, not theirs obviously, but in a dirty environment, a lot of dirt gets in there, and it won't let that contactor move properly when it becomes energized. It can't travel properly, so you get half a connection. So maybe it's not an electrical problem, maybe it's a mechanical problem. So my point is that look at it from a systems level thing, and don't dial in on something too tight too quickly. Think very basically. The guys and girls at Hopkinsville did that. They just basic common sense, using your visual. They didn't have the thermography camera or anything. Didn't need it really. So just look very basically, and they were able to solve their problem. Figure it out first, and then replace that contactor. And then look where someone may have been working last. Usually, when you get a call, something has happened. In the industry, I've seen. I was working here before we went on a break, and all they did was they brought a fork truck load of material over there. Well, let's go look, see where the fork truck went. Sure enough, the fork truck mast has hit a piece of conduit, it's ripped stuff out. Maybe somebody drove off and didn't say anything about it, or maybe somebody mashed something or bumped into something, maybe hit an e-stop or something like that. Just look very basically, and look where the folks have been last. That's typically a good way to start your troubleshooting process. And use all the tools in your toolbox. And we talked about it, use your eyes, use your ears, use your nose. You'll smell things. You'll smell things burning. Some of you smelled some transformers in the lab get a little hot and start to burn. And use your hearing. Use your sense of touch very carefully, particularly around rotating machinery. But use it very carefully. And these things, they'll really help. And as I've said before, I shouldn't have to say this again, but don't use your sense of taste. I can't see any application where you're going to use your sense of taste, okay? So just don't do that. So anyway, this is just, like I said, a real-world example I wanted to kind of follow up with you a little bit with, and hope it was of some help to you. Hope you enjoyed it. Again, I want to thank the good folks at Hopkinsville Brewing Company. For those that are old enough to visit, go down there and see them. I've got a really neat place down there, and there's some good people to talk to, sit around and visit with. So anyway, thanks for watching. Keep going in the troubleshooting, and we're going to keep working on it throughout the rest of this class. Hope you have a good weekend, and we'll talk to you soon. Thank you.